All right, so first thing I want you to do is look at your Unit 4 Objectives worksheet. I actually went over this yesterday, so you had it, something like this anyway, similar, but law of definite proportion, talking about how the compounds react with one another. Um, the way they bond, the way they connect, there's always going to be a certain ratio between the elements that make up the compound. Okay. Law of multiple proportions, when two or more elements combine to form compounds, the mass is combined in simple whole number ratios that we can figure out. So from this, we're going to be able to kind of try and deduce formulas. All right, that's been the point of worksheets 3 and 4 that we've been working on. And I'll come back to this. I'm just going to start with 6, and then we'll go back through the other ones, since I already had it written up here from last hour. But I'll come back to it. But in your worksheet 3, so I put it in red here. I mean, that's really important. If you go back to that, what it was we had these ratios, these different masses. Like in number 1, we had these two compounds. And we figured out in the first one that the mass of oxygen to the mass of carbon was like 1.33 grams to 1, okay? And we were kind of looking at a couple different hypotheses. Like one was, what if so anyway, a couple hypotheses. One, that all the atoms had the same mass, and the other one was like, what if elements have different masses, which we know to be the case, all right? And so the first time we drew a compound, we did something like this. We said, okay, because this could be carbon with a mass of 1. And then a little bit bigger, we'll draw oxygen. And if that had a mass of 1.33, that would work, because then the ratio between those masses would be 1.33 to 1. Thing is, then we went to the second compound that was also oxygen and carbon. But the ratio of those masses, when I divided, I came out with 2.66. All right, so it was a 2.66 to 1. So then if we looked at it and just tried to do like one atom of each, it would still be that carbon has a mass of 1 and oxygen has a mass of 2.66, okay? Which doesn't really make sense, but then when we look back at this compound 1, we do notice that this is twice as much. So that mass ratio would work out if instead of this, we had something like this. So carbon still with its mass of 1, and each of the oxygens, just like they were before, having a mass of 1.33. And now that kind of solves a problem for both compounds. And then we can go from there and go, okay, so what's the formula for this first one? And with this, you got to understand the subscripts, okay? However many atoms there are in a compound, you write that number as a subscript, which is the little number to the bottom right. But if there's only one, you don't write 1. So since there's 1 carbon, 1 oxygen, that would just be CO, right? This one carbon and 2 oxygens, so we would call this CO2. Those are carbon monoxide and carbon dioxide. So that's from worksheet 3. You'll get similar problems like that, okay? So back to that, if you need to finish writing that. So I'll go ahead and pause there for a sec. as I go through this, I'm going to kind of go quickly and just tell you really, if you want to check what you have and just kind of make notes along with it, what do you really need to know for tomorrow's quiz? If you go through this stuff, guys, and you prepare for tomorrow's quiz, which is going to be a biggie because it's going to be hard to do any retakes or anything. This is going on this marking period. We are at the end of the marking period. All right, so you need to do well on this tomorrow, not waiting for later. You got to set an alarm in your phone or something to remember to study and look over stuff. You'll be in good shape. Realistically, this test is not that hard, okay? I think the majority of any stress that you might be feeling might just be narrowing it down to exactly what you have to do on there, which is exactly what I'm going to tell you. All right, so first of all, we have to be able to distinguish between pure substances and mixtures. All right, so pure substance. Okay, so a pure substance is when we have a substance that consists of only one type of particle. Okay? So what that means, remember the particles are like the pieces. All right? So the individual pieces are all going to be the same. Mixtures are going to be different. So pure substance, if I look at a pure substance, all right, a couple of examples of pure substances. If I look at this substance here, okay, there's 5 pieces. There are 5 particles, and each particle is identical to the other particles. There's not any different particles, right? In there, there's only one type of particle. I can even do this. Okay, so that one has 3 pieces. All right, now you'll notice the atoms are not the same. There's more than one type of atom, but when we're talking about pure substances and mixtures, we're only looking at the pieces. So are all the pieces the same? Yes, they are. So all the particles are the same. That's a pure substance. All right, now mixtures. Have more than one type of particle. So if we look in those boxes that represent a certain volume, in a mixture we would see different things, okay? Now maybe we see some dots like this. Okay, so far it's a pure mixture. Or sorry, so far it's a pure substance. There's only 3 particles and they're all the same. So I'm going to add another type of particle, something like that. So now if I ask myself, if I just look at that picture, are all the pieces identical to one another? No, they're not. There's more than one type of particle in there. This is a mixture. Here's another example of a mixture. Oops. It's supposed to be 2 dots just like the other ones. All right. Now, one thing I didn't say a whole lot about was talking about the types of mixtures. You can actually have a couple different types of mixtures. Just if you look at the components in the mixture, are they all the same throughout or are there different parts? Like if I look at this first one, there's 2 distinct parts. The top is different than the bottom. See that? Whereas this, all the things are kind of just spread out evenly. This is what's called a heterogeneous mixture. All right? Meaning there's hetero means different, so there's different parts. This is called a homogeneous mixture. The whole thing is the same throughout, composition throughout. If I take a piece of that, I'm probably going to get the same stuff in one area as in another area. All right, so it also mentions, what about separation techniques? Okay, so when we talk about pure substances and mixtures in terms of separation techniques, understand that pure substances and mixtures, we're going to have to do different things depending on what it is, all right? And this is where we really got to have a good understanding of chemical and physical changes. So make sure you understand what chemical and physical change means, okay? Which is really easy. All you got to say is, are we making something new? If we're making something new, if we have to make something different than what we started with, that's a chemical change. If it's still the same stuff at the end, that's physical. All right? So with pure substances, we're going to get to this more in a little bit when we talk about pure substances being elements and compounds, which you might be able to just tell from this top picture, because that's what we had here was element here and a compound here. But in pure substances, the only ones we can break down are compounds. We can break them down into their individual atoms. But the thing is, okay, I've got more than one type of atom I can separate, but they're chemically bonded. So pure substances, we're only going to be able to change those and separate the smaller parts by chemical means, all right? So we have to do some kind of reaction that changes what we have. Like if I had H2O and I wanted to separate it into hydrogen and oxygen, it's going to require a chemical reaction. Now mixtures, on the other hand, we can separate those out by physical means, and I'll talk about those more in the next objective. Okay? Okay, is everybody good with this? All right, so describe how to use characteristic properties to separate the components of a mixture. Identify the separation technique, name and equipment. Identify the property used in the separation. Not going to have to worry about all the equipment and all that stuff, but you should understand what are ways that we can separate mixtures. So first of all, we can use properties like the size of the particles. Okay, so if we're separating them based on the size of the particles, we might do something like filtration. Okay, so something to separate the parts out physically, like a strainer. Okay, we could use filter paper. All right, another thing we can do is use the fact that in the mixture we have different boiling points. Okay, so in a compound, the properties or in a pure substance, the properties throughout the substance are going to be the same. But in mixtures, the properties are still the individual parts, just mixed. Okay, so if I have some kind of mixture like water and salt, all right, we still have the properties of water, we have the properties of salt. I can use the boiling point of water, the fact that it's lower than salt, to boil the water off. And I could either collect the water and have that separate, or just say that I separated the salt out because that would be left behind. All right, so boiling point, what we call this process is distillation. We can also separate things based on whether or not they're magnetic. Like if I had a mixture of iron and sand, I could use a magnet to get the iron out because it's magnetic. It would leave the sand behind. We can use densities because in densities, the densities, there would make different layers that I could then separate. Layers, layering. And another one is solubility. Okay, so we saw a little bit about this in the video we watched with the gases, talking about solubility. Just understand that solubility means something can dissolve. All right. So if I have these two things together and only one of them dissolves in water and I add water to it, well, I'm going to have just one thing left behind because the other component will be dissolved. Is everybody good with that? Cool. Say no. All right, number 3, cite evidence for the presence of compounded matter particles. Describe the differences between elements and compounds. Learn the names and symbols for common elements. So let's talk about the elements and compounds. We definitely need to be able to identify the difference between those, all right? So elements and compounds are both pure substances. The difference is that elements, each particle, so each piece is only one type of atom. So before, when we were identifying the difference between pure substances and mixtures, it was about, are the particles the same or not? Now what it is we're looking at the individual particles and saying, are all the atoms the same or not? So in an element, we could see something like this, where they're just dots. So I've got 4 pieces there. I'm just going to look at the individual pieces, okay? One of those pieces is just one black dot. Well, it's just one dot. That means that there's only one type of atom, okay? Now, even if I saw something like this, if you remember I was talking about the diatomics, where it's 2 atoms stuck together, still an atom, or sorry, still an element, because if I look at each particle, okay, each particle only consists of one type of atom. Does that make sense? But with compounds, if we look at each particle, more than one atom, they're stuck together too, so we say they're chemically combined. They're stuck together by these things called chemical bonds. All right. So if we look at compounds, we'd see something like this maybe, like we had earlier. Okay, so if I look at that particle, that one piece has two different types of atoms. There's some black atoms and there's a white atom. So it's not just one piece. And of course, if you do any particle models, make sure you don't just do one particle. Do more than one particle on those. Learn the names and symbols for some common elements. I mean, you got to be familiar with those a little bit, but not too much. We did have some notes that we took, and I gave you a handout about common elements. And I said, hey, just hang on to this for Wednesday and turn it back in with your written notes that we've taken in this class. I'll take a look at those and give you points. All right, so be aware we do have some notes. If you go back through Google Classroom, you'll see which ones those were. But now, along with this, when we talk about compounded matter, you got to be able to see something like H2O, all right, and talk about the ratio of the atoms. So if I said here with H2O, I said, what is the ratio of H atoms to O atoms? You should be able to tell me that it's a 2-to-1 ratio, okay? There are 2 hydrogens for every 1 oxygen. If I had something like CO2, okay, and I want to know the ratio of carbon to oxygen, you should be able to tell me that that ratio would be 1 to 2. All right? If I had something like HF3, the ratio of H to F would be 1 hydrogen to 3 fluorines. Does that make sense? And by the way, talking about compounds and mixtures and talking about the symbols for common elements and things like that, you should be able to recognize if we have a capital letter in a symbol, that's telling you that that's an element. Like if I saw just AG, okay? So what's in that? Well, it's just one thing, AG. That would be an element, all right? If I saw something like this, H2, that tells me it's 2 hydrogens stuck together. That's diatomic. How many types of atoms do I have in that molecule? Still just one type of atom. That's still an element, right? And then I see something like what I drew over here, the H2O. How many capital letters do I have in that formula? I have an H and I have an O, and they're stuck together too. All right, so that would be a compound. CO2, a capital C, capital O. That's more than one type of atom. That's a compound. H and F, more than one type of atom, compound. Now we can have more than one type of atom not stuck together. What would that be called? A mixture, like if I had this. H2, and then I did something like wrote and Cu, okay? There's more than one type of atom there, but they're not stuck together. There's an and in there, which tells me that that's a mixture. Otherwise, if it was a compound, I would have stuck them together and left the and word out. Pizza cake. Pizza cake. You guys good with all that? Still writing? Oh, and no laughing in school, please. Okay, Avogadro's hypothesis. This is what we need to know. And the key on this, not just that equal volumes of gas have equal number of particles, it's key to understand that they have to be at the same temperature and pressure, because if you change either of those, it's a whole different ball game. All right? Got to keep the temperature and pressure constant. We also had, I think, worksheet 2 where we saw if we kept the same number of particles within each box the same. Like if we had 4 particles in one box combining with 4 particles in another box, and then we made like more than one volume, if you remember that from worksheet 2. Okay, keeping the same number of particles in one box and then making a larger volume of particles that we produce becomes a problem. Okay, we might have to do something. If we make more volumes of gases, we can determine that we actually had some of those particles be diatomic. All right, meaning the two atoms of the same type stuck together. All right, so we start to see some things with compounds. Do you guys remember all the diatomic elements? Do you remember all the diatomic elements? There you go. You got it. HF brinockel. Good. Hydrogen, fluorine. Not that that's on there. You don't even need to know it. This is really pretty easy. Is everybody good with that? Can I erase that? Owen. Okay, so state features of Dalton's model of the atom, like all matter is composed of particles called atoms. Atoms can chemically combine. Oops. But atoms are not destroyed. Okay. The other thing is atoms of different elements have different masses. And then we already did number 6, right? So all that stuff I went over, that's it. Like I said earlier, the chemical and physical changes, make sure you know the difference between chemical and physical changes. Again, chemical, got to make something different than what we started with. Physical, we still have the same things we started with, we just separated them out, right? And that's it. If you go over this stuff tonight, maybe look back at your old worksheets. What were you doing on those? You should be good to go.